All right, so we have the functions f of x equals x and g of x equals x squared. And we have their intersection there, and it intersects and forms region S. And what we want to do is we want to use the Washer method. And the formula for the Washer method is pi and the definite integral from a to b of big R of x squared minus little r of x squared dx. So in this case here, in the first problem, we want to rotate this region about the line y equals -1, all right? So when I'm using the Washer method here, if I'm rotating around a horizontal line, that means I'm going to be with respect to x, so that my partition is going to be vertical here, all right? So we want to use this concept when we're doing this, and this has helped my students. We want to think of when we are with respect to x, we are doing top minus bottom. And the bigger R is, when we look at our yellow partition here, which part of it is farther away from the line of rotation? Is it the top of it or is it the bottom of the partition? And we can see that the line y equals x is at the top of that yellow partition. So we're going to use our big R is going to be x minus a -1. We're doing top minus bottom. And then little r would be the bottom of the yellow partition is closer to the line y equal -1. So that becomes little r. So again, it's going to be top minus bottom. So it'd be x squared minus a -1. And my limits of integration, we can see that we start at 0 and it ends at +1. So our limits of integration are from 0 to 1. So we would have x minus -1, the quantity squared, so that would be my big R, minus x squared minus a -1, my little r squared. And if we simplify that, we would get pi, definite integral 0 to 1, x plus 1, quantity squared, minus x squared plus 1, quantity squared, dx. All right, so now let's use the same example, and let's see how things change when we change the line of rotation. So now let's rotate the region S about the line y equal 1. Now look what happens. We're doing the same concept here. I'm looking at that yellow partition, and what is farther away from the line of rotation? Now the bottom of the yellow partition is farther away, so that distance becomes my big R. So now we're using the bottom curve in our top minus bottom. So our top function would be 1, the line of rotation, minus the bottom, which would be the curve, x squared. And that represented in my green distance there. And then little r would be the shorter distance from the line of rotation, top minus bottom. So it would be 1 minus x. So what we would get pi times the definite integral 0 to 1 minus x squared, the quantity squared, minus 1 minus x, the quantity squared, all dx. In our next example, we're going to rotate the partition about the line x equal 1. So in this case here, now the partition, remember our partitions need to be perpendicular to the axis of rotation. So now we have a horizontal partition, which means we are now going to be with respect to y. And just to make things easier, instead of using function format, I went y equals the functions and I solved for their inverse. So the inverse of y equal x is easy, it's just x equal y. And the inverse of y equal x squared would be x equal root y if we are x greater than 0. Okay, so we can see our partition here. Now it's horizontal, and I have my formula. Now the limits of integration are going to be on the y-axis now. So my limits of integration will remain the same because that point it intersects at goes from 0, 0 to 1, 1. So we have the same limits of integration as we do with respect to x. Now we're going to use the same concept, but instead of top minus bottom, we're going to calculate distance by right minus left. So again, we see which curve is farther away from the line of rotation, x equal 1? Well, we can see that x equal y is farther away. So if I go right minus left, it would be 1 minus, and I have to do this with respect to y, so it'd be 1 minus y, the quantity squared. And that's my big R. My little r now would be from the line of rotation 1, which is the right side of it, minus the left, which is square root of y. So my formula would be pi times the definite integral 0 to 1 minus y, the quantity squared, minus 1 minus root y, the quantity squared, dy. Okay, in our last example, we're going to switch the line of rotation to x equal -1. So notice how now the big R has switched. So we're using the distance farther away on the yellow partition to x equal -1 lies on that square root of y curve. So big R would be square root of y minus -1, and little r would just be y minus -1. So we plug those into our formula, and once we simplify that, we're going to get pi times the definite integral from 0 to 1, square root of y plus 1, the quantity squared, minus y plus 1, the quantity squared, all with respect to y. Okay, I tried to do 4 problems in one here just to give you the concept of rotations using this top minus bottom or right minus left. And this seemed to help my students through the years. I know it can be very confusing where you get multiple formulas in a calculus textbook. So I hope this helps. If it did help you, please like and subscribe. Thanks for watching.